So we'll start with the fourth lecture of rotational dynamics. Okay. So before we start the lecture, let's discuss something about strategy and planning. Strategy and planning in the sense we often have heard that motivation doesn't work. What works is the discipline. Okay. So here's a video that I have watched in YouTube, and it's a very intuitive video. Okay. That what's the difference between strategy and planning? Okay. And you might have a question, sir. We already know these things. Don't repeat to us. It's not like that. See, what it basically says is that planning is something that you are going to do in a day. That means you plan out the things that you're going to do in a day. Okay. Whereas strategy is keeping the track of the things that you have achieved during the day. Okay. And he also further on goes on to say that planning does not work. Okay. Planning, see, there might be some emergencies. There are different kind of emergency. Okay. Suppose you plan to study, some relative failing. Okay, you have to go visit them, or different kind of emergencies come. Strategy, however, is nothing but every day if you keep a track of what you have achieved during the day, you get to decide means, acha, next day I can do this much easily. Okay, so let me do this much by that parameter. I can cover this much in this much time. Okay, so strategy is keeping an account of what you have already achieved during the day. Okay, and start by keeping the track record or keeping the account of or have an accountability of what you have achieved during the day instead of planning your syllabus or doing this kind of thing. Start doing things, keep track record, and then based on practical parameters or based on normal things. Normal thing means suppose you have done 10 questions in a day. Okay, do not plan like I'm going to do 30 questions tomorrow. Okay, so if your normal target or normal achievable target is 10, tomorrow also you're going to do the same number of questions, either 10 questions or 9 questions or 11 questions. You're not going to suddenly increase it to 30 questions. Even if you increase it to 30 questions, your efficacy or your effectiveness of doing those 30 questions won't be that much. Okay, so normally what you have achieved, keep a track record of that, and based on that, keep doing the things and keep developing the things. Okay, and that's what we call strategy. Okay, so after this, we'll go just keep a track record. Okay, what I'm trying to say is just create a notebook or homework book or classwork book or daily routine book and write down the things that you have done during the day. Means write down the number of questions from suppose you have studied physics today. You have to solve 10 questions of physics. Okay, so write down 10 questions of physics. Okay, tomorrow suppose you're studying chemistry and you have solved 10 questions of chemistry. Write those down. Okay, and that's what effective strategy is: keeping a track record of what you have achieved and deciding your next outcome or next thing that we're going to do based on that track record. Okay, so let's start with our questions without any further nonsense. Now this question, okay, in this question there is a horizontal table, okay, and a rod is kept on this horizontal table. Okay, the rod is fixed at one end of the table. That means the rod is free to rotate like this. Okay, I'm seeing this rod from the top. Okay, so let me draw the rod. This is a rod of length L that is fixed at the horizontal table. Okay, that means the rod is free to rotate. This is the rod. This is free to rotate. That means I'm seeing this rod from the top, and this rod is free to rotate. This rod is free to rotate. Okay, a constant force is applied at the tip of the top. Okay, the magnitude of this force is constant and the direction of this force is also constant. The question is asking, okay, see what will happen if I apply constant force here? The rod will tend to rotate. So let's say after some time the rod rotates by theta angle from the horizontal. Okay, theta angle, and a constant force was already there. Okay, we have to find out the angular velocity of this rod as a function of theta. Okay, that means calculate a formula or make a formula such that when I input the value of angle theta, I get the value of angular velocity. Understood what was happening? A constant force was applied. Okay, in this table, a rod was kept. It is free to move about one end. Okay, and a constant force was applied. So when the rod is rotating, find out the angular velocity of the rod as a function of theta. This is our question. And our approach out here. So our approach out here would be simply using work energy theorem. What is work energy theorem? Change in kinetic energy of the body is equals to work done by all the forces. So in rotational mechanics, what would be work energy theorem? Change in kinetic energy of the body is equals to work done by all the torque. So change in kinetic energy of the body is equals to work done by all the torque. Okay. And since this work done and kinetic energy are scalar quantity, in some questions you can combine the work done by force and work done by torque. That means total change in kinetic energy, rotational kinetic energy plus translational kinetic energy is equals to work done by all the torque acting on the body plus work done by all the forces acting on the body. You can write it like that also. Okay. So since total change in kinetic energy or change in kinetic energy translational plus change in kinetic energy rotational is equals to work done by all the forces plus work done by all the torque acting on the body. Okay, since we're not concerned about translational kinetic energy out here, okay, let me just use this change in rotational kinetic energy is equal to work done by all the torque. Okay, change in rotational kinetic energy is equal to work done by all the torque, or half I omega final square minus half I omega initial square. This is nothing but changing kinetic energy is equals to work done by torque. What are the torque acting on this body? The only torque acting on this body is due to this force F, isn't it? And the value of torque is nothing but R cross F. And work done by torque is torque dot theta. Then fine. What is the initial angular velocity? The initial angular velocity was 0 because it is starting, no? The original position stationary rod. That means at original position or initial angular velocity, it was stationary. So out here, initial angular velocity would be 0, isn't it? So this out here is 0. Okay, this out here is 0. Let me just. This out here would be 0. Okay, so half I omega final square. But omega final is nothing but the value of angular velocity at theta. That means at this position, I'm calculating the omega as omega final. Okay, and omega initial was at stationary position or at the beginning. Okay, is equals to dot product of torque dot theta. Work done by force is equal to force dot displacement. Work done by torque is equal to torque dot angular displacement. Now, what is torque? Torque is nothing but R cross F, isn't it? Okay, R is nothing but length of the rod. Okay, cross F. Now, what is the angle between F and L? So, angle between F or force vector and L vector. L vector is nothing but starting at this point. This is our origin. Okay, and the L vector is in this direction. So, angle between force vector and L vector is nothing but theta. See, if this is our L vector or torque vector, sorry, L vector, the angle between L vector and F vector is nothing but theta, isn't it? Because if this angle is theta, this angle is also theta. This angle is also theta. So R cross F is nothing but magnitude of R into magnitude of F into sine of angle between R and F, which is nothing but theta. So RF sine theta is nothing but the torque due to this force. Now, what is the direction of this torque? Torque is a vector quantity, no? So this entire thing would be a vector quantity. What is the direction of this torque vector? The direction of this torque vector is nothing but inside the plane of vector. This torque is axial vector. Let's see this one. Okay. If you use your right hand, L cross F, okay, or L sine theta cross F is nothing but torque. So torque is inside the plane of paper. Okay. So remember this one. The direction of torque is nothing but inside the plane of board or inside the plane of paper. Just use your right hand. First vector, second vector, resultant vector. Okay. Thumb is the first vector. This finger is the second vector. Middle finger is nothing but the resultant vector. So if you use R sine theta cross F is nothing but this vector, or you can also use L cross F sine theta or L cross F sine theta is equals to in this direction. So this torque is nothing but inside the plane of paper. Okay. And what is the vector direction of this theta? If you curl your right hand in the direction of angular displacement, you can even see that this angle theta, the vector of this angle theta or vector of this angular displacement is also inside the plane of paper. Okay, so torque is also inside the plane of paper. Theta is also inside the plane of paper. Okay, so the angle between torque vector and theta vector is nothing but 0 because both the vectors are inside the plane of paper. Understood this much? So torque dot theta is nothing but torque into theta into cos of angle between torque and theta or cos of 0. Okay, so I can write it as half I omega final square is equals to torque theta into cos of angle between cos of angle between torque and theta, which is nothing but 0, and cos 0 is nothing but 1, isn't it? Okay, now if I substitute torque, okay, what is the value of torque? Rf sine theta, or I can easily say that half I omega final square is equals to torque Rf sine theta into theta into theta, this theta. Okay, now if I just, okay, now what is the moment of inertia? What is the moment of inertia of this rod above this origin? It is nothing but ml square by 3. The moment of inertia of a rod is nothing but ml square by 3 about the end. So half I, okay, half I omega final square. Omega final square is equals to Rf theta sine theta. I'm just rearranging this. Okay, Rf theta sine theta. Rf theta sine theta. Now if I bring or ml square into omega final square by 6 is equals to Rf theta sine theta. Rf theta sine theta. What is the value of R? R cross F. What is the value of R? The value of R is nothing but L only, because R cross F, the length is nothing but L only. No, this is the value of R that I have taken. So I'll replace the value of R by L. This L and this L square will get cut. Okay. So the value of omega final square will be nothing but omega final square is equals to 6a theta sine theta, okay, by, okay, 6f theta sine theta by ml divided by ml. Okay, when I see this equation, I'm taking this ml by 6 to the right hand side. So 6f theta sine theta by ml is equals to omega final square. And if I remove the square, omega final is nothing but under root of 6f theta sine theta by ml. So the angular velocity as a function of theta is nothing but this parameter. So this is our answer. So if when you input the value of theta out here, you will get the value of angular velocity. So this question was fairly simple enough. Okay. Now see this question out here. Okay. This question is very similar to the questions you have done in Newton's law of the function. Okay. But there is a subtle difference out here. The difference is, see, in Newton's laws of motion, whenever you used to have a pulley and body system, I said something like whenever the strings are same or whenever the rope is same, the value of tension force is same. That won't be the case out here. Now you might ask why. See, in Newton's law of motion, this rope and this pulley was independent. That means this rope was sliding over the pulley. Okay, there was no friction, nothing. Okay, this rope had no interaction with the pulley. However, in rotational dynamics, the friction force from this rope, the static friction force, okay, or the contact force from this rope is used to accelerate this pulley. Okay, so the tension force on this side won't be equal to the tension force on this side. This much is understood. The difference out here is tension force of this side would be very different from tension force on this side. And that difference in tension force, that means if T2, if suppose M2 is higher or the value of mass 2 is higher and the mass 2 is accelerating downward, mass 1 is accelerating upward. That means this tension or the difference in tension force, T2 minus T1, is actually rotating the pulley. Okay, what I'm trying to say out here is in Newton's laws of motion, the value of T out here and the value of T out here will be equal. However, in this question, okay, or whenever you're studying rotational dynamics, out here the value would be T1, out here T1, out here the value would be T2, out here T2. And this difference in tension force, T2 minus T1, okay, or T1 minus T2, whichever is higher. Okay, T2, suppose I'm assuming T2 is higher. So T2 minus T1 is actually used to rotate the pulley. That means this difference in tension force is actually rotating the pulley. Okay, in this kind of scenarios. Make a note out here. The difference in tension force, T2 minus T1, is actually rotating the pulley. Actually rotating the pulley. Okay, the torque due to this tension force T2 minus T1. Torque due to T2 minus torque due to T1. Okay, understood the concept out here? Okay, now let's apply our free body diagram. And before we start applying free body diagram, let's use the constant motion to fix the acceleration. I'm assuming mass M to be higher. Okay, you can also assume mass M1 to be higher, it doesn't make a difference. The relative acceleration, that means if M2 is going down with acceleration A, M1 is also moving up with acceleration A. This is the concept of constant motion because the length of the rope is same. Okay, so if M2 is moving down with acceleration A, M1 is also moving up with acceleration A. And this point, okay, the point of contact at that edge is also moving down with acceleration A, isn't it? So angular velocity alpha is nothing but A by R. Why is that? Because we know that A is equals to R cross alpha, not R cross alpha. A is equals to alpha R, isn't it? We know that A is equals to alpha R, V is equals to omega R. We know those kind of things, no? So from this equation, we know that angular acceleration alpha is equals to A by R. Why? Because if this is moving down with acceleration A, this is moving up with acceleration A. Because the length of the string is constant. Okay, the string won't get elongated or compressed. Understood? So if this is moving down with acceleration A, if this body is moving down with acceleration A, this point out here would also have an acceleration A in this direction. So if this point out here is having an acceleration A in this direction, that means if this point is having acceleration A in this direction, A is nothing but alpha into R. So angular acceleration alpha would be A by R, where R is the radius of the pulley. Understood this much? So this is our constant motion. Now let's write down the equation. Okay, if I see this mass M1, okay, downward is M1G, upward is T1, and the body is moving up with acceleration A. If I write my equation, it will be nothing but T1 minus M1G would be equals to M1A. Similarly, if I see this body T2, okay, or M2, Let me draw my body M2. Okay, M2. Out here also M2G upward T2. So out here, the body is moving down with acceleration. So M2G minus T2 is equals to, this is equation number 1. Equation number 2 is nothing but M2G minus T2 is equals to M2A, isn't it? Okay, M2A. This is our equation number 2. And equation number 3 would be taken from the pulley. So if this is our pulley, okay, this is nothing but T2. This is nothing but T1. And the pulley is rotating with angular acceleration alpha. So out here, torque due to T2. What is the torque due to T2? R cross T2. Okay, or R into T2. Angle between R vector and T2 vector is 90 degrees. See, so sin 90 would be 1. So R T2 is nothing but torque due to T2, which is clockwise in direction. Minus RT1. What is RT1? RT1 is nothing but torque due to T1, isn't it? Torque due to T1 force. Minus RT1 is equals to moment of inertia of this disc or moment of inertia of this pulley into angular acceleration of the pulley. This is our equation number 3. Okay. Now I either have to convert all these linear terms into this angular term, or I have to convert all these angular terms into this linear term. Whichever method you do, the answer will come out to be the same. So since only one equation is from rotational term, I'll convert this term into linear term. Okay. What is the moment of inertia of this pulley? The moment of inertia of a solid cylinder is nothing but mr square by 2, isn't it? mr square by 2. And angular acceleration. Angular acceleration is nothing but a by r. Angular acceleration is nothing but a by r. So if I rewrite equation number 3, I'll get something like RT2 minus RT1 is equals to mr square by 2, mr square by 2 into a by r. So out here r and this square will get cancelled. If I take r common out here, and this r will get cancelled. So I have my remaining equation as T2 minus T1 is equals to m into a by 2. But m is nothing but mass of this pulley. Okay, so this is my third equation. Now solving these three equations, this first equation, this second equation, and this third equation. Okay, this is my third equation. This is my third equation. So solving these three equations, I'll get the value of acceleration first. Then from the value of acceleration, I'll find out the value of T1 and T2. And then after finding out T1 and T2, I'll find out the ratio of T1 by T2. Okay. So all that is left of this question is solving these three equations to find out the value of T1 and T2. Nothing more, nothing less. The physics part of the question is solved. Now just go through the equation part of the question. Okay. Now see, I have to solve the equation part of the problem. Okay. So these are the three equations that I obtained. This is the first equation, okay, that is written out here. The second equation is written out here. And the third equation that I obtained from rotational equation that is written out here. Okay. Now solving this three equation, I have to find out the value of T1 and T2. And I have to divide them. That means T2 by T1 or T1 by T2. The question is specifically asking T1 by T2. Okay. Okay. So how do I solve it? First, I'll take equation 1 and 2. Okay. So if I take equation 1 and 2, T1 minus M1G is equals to M1A, this equation, and M2G minus T2 is equals to M2A, this equation. So when I add these two equations together, I'll get M2G minus M1G plus T1 minus T2 is equals to M2A plus M1A. I've just taken A common out here and G common out here. Fair and fine. Now from this equation, I'll just send this T1 and T2 to the right hand side. So out here is T1 minus T2. When this parameter T1 minus T2 goes to the right hand side, it will become T2 minus T1. Minus T2 will become plus T2, and plus T1 will become minus T1. Okay. Now the third part of the equation is written same as it is, except this T2 minus T1. This T2 minus T1 is written as MA by 2. Okay. I have already obtained from where I got this equation. T2 minus T1 is nothing but MA by 2. Okay. Now in the fourth part, I have just taken A common on the right hand side. If I take A common, it will be M2 plus M1 plus M by 2, isn't it? So the value of A is nothing but M2 minus M1G divided by this entire parameter. This is the value of acceleration. Now you need to remember this value, acceleration. Okay. Now on the third page, I have again written T1 minus M1G is equals to M1A and M2G minus T2 is equals to M2A. Okay. These two equations, T1 minus M1G is equals to M1A and M2G minus T2 is equals to M2A. Then what I did out here was, T1 is equals to M1A plus M1G, isn't it? M1A plus M1G, I've taken M1 common. So T1 is equals to M1 into A plus G. Now what I simply did out here was substitute the value of acceleration. What is the value of acceleration? The value of acceleration that I obtained was this value, M2 minus M1G divided by M2 plus M1 plus M by 2, isn't it? So I substitute the value of acceleration, okay, plus G. I've taken G common out here. So and then I've taken M1 and G common, M1 and G common, and I've written out the entire part. Then I simply took the LCM and added out here. So after addition, what I get was T1 is equals to M1G into 2M2 plus M by 2 divided by this denominator. Similarly, out here, I did m2g minus t2 is equals to m2a. The second equation, I've taken m2 common out here. So t2 is equals to m2g minus m2a. So if you take t2 to the right hand side and send m2a to the left hand side, we'll get m2g minus m2a is equals to t2. So m2g minus m2a is equals to t2. Now out here, I simply took out m2 common, g minus a. I've substituted the value of a out here. This is nothing but the value of a. Okay. Now in this equation, I've taken g common out here. If I take g common, it will be 1 minus this value. And when I've solved for 1 minus this value, I'll get some this value. Okay. So I get T1 is equals to M1G into this value, T2 is equals to M2G into this value. And when I do T2 by T1, see, this portion will get cut out or cancelled out, G would get cancelled out. You are dividing this entire parameter divided by this entire parameter, isn't it? So G and G would get cancelled out. Okay, M2 by M1 into 2M1 plus M by 2, 2M1 plus M by 2 divided by 2M2 plus M by 2 divided by 2M2 plus M by 2. And this parameter would get cancelled out by this parameter. So this is the value of T2 by T1. In the question, it is specifically asking for the value of T1 by T2 to just reciprocal this term to get the answer. Okay. So this was the value of question number 246. Now this question is very similar to the previous question we have done. Okay. In the previous question, what did we do? We draw the free body diagram of this one, and the difference in torque due to tension forces T2 and T1 was used to rotate the pulley. Out here also we'll draw free body diagram of mass M1, free body diagram of mass M2, and the difference in torque or difference in T1 and T2 is used to rotate the pulley. Okay. So in this question, there is mass M1, there is mass M2, and the coefficient of friction between mass M1 and the ground is given as mu. Okay, or given as K. So if I draw the free body diagram of M1, on one side there will be one tension force T1, on the other side tension force will be very different from the this side. And T2R minus T1R is equals to I into alpha. Understood? Difference in torque due to this tension forces and tension forces is used to rotate the pulley. Okay. So out here M1 is being pulled by T1, isn't it? And there is a friction force also, no? Friction force is given by K into N, where N is nothing but M1G. Okay. And if this is moving with acceleration A, this is also come down with acceleration A, and the rotation, angular acceleration, alpha is equals to A by R. We have discussed this thing also in the previous problem, isn't it? The angular acceleration or linear acceleration at this point is equals to A, linear acceleration at this point, the tipmost point is equals to A. So angular acceleration would be A by R. Okay, so this much we have done in before, or this much part of the problem we have done in before. The thing that is asked in this problem specifically is find out the work done by friction force. So let us first find out the acceleration. Okay, what is the value of acceleration? It will come out to be same. The same meaning out here. If I draw out the equation, out here equation is nothing but T minus K M1G is equals to M1A. This is my equation number 1, isn't it? If I draw the free body diagram of block 2, M2, this is nothing but M2G. Out here tension force is nothing but T2, and block is coming down with acceleration A. So I can write M2G minus T2 is equals to M2A. Okay, and if I draw the pulley out here, okay, so for pulley, this side it is T1, this side it is T2. Okay, mass of the pulley is M. So T1, or it is rotating this side with angular acceleration alpha. So T2 into R. T2 into R is nothing but torque on this pulley due to tension T2 minus T1 into R. T1 into R is nothing but torque on this pulley due to force T1. Okay, is equals to moment of inertia of the pulley into angular acceleration alpha. So if I take R common, or let me just write down the moment of inertia. Moment of inertia of this pulley is nothing but mass of the pulley into radius of the pulley square divided by 2. Angular acceleration is nothing but linear acceleration divided by R. Okay, so you get my equation as T2 minus T1 into R is equals to m R square by 2 into A by R. These are square, these are, and these are would get cancelled. So I'm left with T2 minus T1, or T2 minus T1 is nothing but MA by 2. MA by 2. T2 minus T1 is nothing but MA by 2. Okay, so I got my third equation. Let me write down my third equation. My third equation is nothing but T2 minus T1 is MA by 2. Okay, let me, okay. T2 minus T1 is equals to MA by 2. This is my third equation. How did I get my third equation? This equation is got from the torque equation. T2R minus T1R is equals to moment of inertia I mr square by 2, I is nothing but mr square by 2 for the pulley, into alpha. Alpha is nothing but linear acceleration divided by r, or linear acceleration divided by capital R, where r is nothing but the radius of the pulley by capital R. Okay, this much is understood. So we have found out three equations. Now solving these three equations, I'll get the value of acceleration. So let's do it quickly. Okay, now see out here. These were the three equations that we got. T minus k1 mg. Okay, from this one. Okay, from this equation. The second equation, m2g minus t2 is nothing but from out here. And the third equation is nothing but t2 minus t1. This is nothing but the torque equation. Okay, torque equation was obtained from here. Now, if I simplify or if I solve these three equations, how do I solve these three equations? First take 1 and 2, equation 1 and 2, add them together. If I add these two equations together, what do I get? m2g minus km1g, m2g minus km1g, plus t1 minus t2, plus t1 minus t2 is equals to m1a plus m2a. On the right hand side, we have m1a plus m2a. In the second step, I have taken g common out here, okay, and separated it out. And then m1 plus m2. That means I have taken a common out here. In this entire term, I have taken a common. And I have also sent t1 and t2 to the right hand side. So minus t2 would become plus 2 on the right hand side, and plus t1 would become minus t1 on the right hand side. Okay. And then again, the same thing is written down out here. Same thing is written down out here. Except this t2 minus t1 is substituted from equation number 3. Okay. This t2 minus t1 became ma by 2. See equation number 3. T2 minus t1 is nothing but ma by 2. So t2 minus t1 became ma by 2. Okay, the same thing is written down out here. Okay, on the right hand side, I have taken m1 plus m2. From the third variable also I have taken a common. Okay, so it will become m1 plus m2 plus m by 2. If I take a common from all the three terms, I'll get m1 plus m2 plus m by 2. And then I have written down the acceleration a as this entire variable divided by m1 plus m2 plus m by 2. Understood? So this was the entire thing for finding the acceleration. Okay. Now if you observe the question very carefully, okay, just observe the question. The question is asking, okay, the thread, assuming the pulley friction, find out the work performed by the friction force acting on the body m1 over the first t second after the beginning of motion. Okay, that means you have to find out the work done by friction force. And what is the formula for work done by any force? Work done by friction force is nothing but force into displacement, or friction force dot displacement, isn't it? Work done by friction force is nothing but the value of friction force and displacement. Okay, how do I get the displacement for over a time of t? That means what is asking is at time t is equals to 0, the entire system was at rest. Okay, after a certain time t, let's say after 5 seconds t, or after 10 seconds, after t is equals to 10 seconds, there would be some amount of displacement, no? How do I get the displacement after time t? If the initial velocity is given as 0. Okay, in the question, the system was released from rest. Okay, assume to be uniform disk. Read the question. See, the coefficient of friction body m1 and m2, and the pulley of mass m is at the thread does not slip over the pulley at moment t is equals to 0. See, the thread does not slip. It means the entire system was at rest, no? At t is equals to 0. And at t is equals to 0, the body starts descending. That means it started accelerating, isn't it? That means initial velocity of the body was equals to 0. Okay, this line means the initial velocity of the body was equals to 0. We have to find out the work done by friction force. So in order to find out the work done by friction force, we need to find out the displacement. So in order to find out displacement, we know that displacement is equals to ut plus half at square, where a is nothing but the acceleration of the block. Okay. Okay. Initial velocity is equals to 0. So displacement of the block over first t second is nothing but half a into t square. Okay. So if you give out the value of t, we'll get the value of displacement. Okay. Now what is a? What is acceleration out here? Acceleration out here is nothing but the acceleration of block m1, which is equals to this value of a. And this value of a was obtained out here, isn't it? A has this value. You obtained by using equation. Okay. So this value of a would come out here. So displacement over the first t second is nothing but half a. A is nothing but m2 minus k m1g. Okay. m1g divided by m1 plus m2 plus m by 2. Okay. This is a into t square. So you got the value of displacement. Force into displacement, friction force into displacement is nothing but work done. So work done by friction. Work done by friction is nothing but friction force. What is the value of friction force? The value of friction force is nothing but k into m1g, or coefficient of friction into m1 into g, or coefficient of friction into normal reaction force, which is equals to m1g. So k m1g, which is nothing but the value of friction force into m2 minus km1 g divided by m1 plus m2 plus m by 2, okay, plus m by 2 into half. This half should also be taken, isn't it? This half into half t square. So this is my answer. Okay, this is the work done by friction force. Now I'll do one more thing out here. In the comment section, write down why I did out this thing. Okay, I just multiply the entire thing by minus. In the comment section, write down why did I put a minus out here. Okay, see, out here there is a minus, no? Okay, you have to write down in the comment section why did I put a -1 or minus out here. So that was the end of question 247. Our answer is this one. Okay. Now in this question, there is a wall. Okay, and both of these walls have friction. Now there is a cylinder out here, and the initial angular velocity of the cylinder is given as omega. Okay, so let's understand the situation. Suppose this is a cylinder, this is both the walls. Okay, initial angular velocity is given as omega. What will try to happen? Okay, this wall or this cylinder, okay, will experience a friction force opposite to the direction of angular velocity, isn't it? Okay, and that would cause retardation. So after a certain time, this cylinder would come to a stop, or this cylinder would stop rotating. Okay, the question is asking how many turns would the cylinder accomplish before it stops. Okay, that means what is the number of turns the cylinder rotates before stopping. This is similar to car braking problem in kinematics. Okay, a car is moving with certain velocity and suddenly the brake is pressed. What is the distance before it stops? The same kind of analogy in rotational dynamics. Out here, we do have to understand the free body diagram. Free body diagram means, see, this wall also has coefficient of friction k. This wall also has coefficient of friction k. Okay, so we'll start with the direction of friction. Okay, so there are two contacts this cylinder makes with the wall. Contact this one and contact this one. Let's name this contact N1. Let's name this contact N2. Isn't it? There are two contacts of the cylinder with the wall. Contact N1 with the vertical wall and contact N2 with the horizontal wall. This much is clear. Now let us figure out the direction of friction forces. Okay, see, friction forces opposes the relative motion, or tends to oppose the direction of relative motion. So look at the surface, look at the surface and the wall. Okay, look at the vertical surface. When the ball is, or when the cylinder is rotating, okay, suppose the friction force was very strong. Okay, assume the friction force is very strong. Okay, it won't let the cylinder slip. If the friction force is very strong and if the cylinder is rotating like this, okay, if the friction force is very strong, it is tending to go up, no? This block or this cylinder is tending to go up. So which direction is the friction force? See, if I rotate it like this, that means this surface that is in contact with this part of the wall is trying to go down, isn't it? It's trying to go down. So if this surface is trying to go down, okay, friction force from the wall into this surface will act in upward direction, isn't it? If this is rotating with angular velocity omega and this surface is trying to go down, the friction force will act in upward direction, isn't it? So friction force from wall 1 would act in upward direction. Okay, now see the lower portion. This block is trying to rotate or is trying to slip like this. Okay, it's trying to rotate like this. So this bottom surface is trying to slip in this direction, isn't it? It's trying to slip in this direction, or this bottom surface is trying to go in this direction. So the friction force on the bottom surface would act in the leftward direction. So this is nothing but friction force from the bottom wall, Fr2. Okay, and this friction force would cause an angular acceleration opposite to the direction of angular velocity. This much is clear. Okay, now tell me one thing. What is the linear acceleration of this cylinder? Linear acceleration of center of mass. Okay, due to all the forces N1, Fr1, N2, F2, Fr2. These are linear forces, no? Of course, this will produce some torque, but let us analyze the situation linearly. Okay, what is the linear acceleration of center of mass of this cylinder? Linear acceleration of center of mass is 0, because the center of mass, this cylinder, is continuously rotating at the surface, no? It is not going anywhere, neither moving up nor moving down, neither left nor right. It is continuously rotating out here, and the angular acceleration is acting in opposite direction, isn't it? So the linear acceleration of the center of mass of this cylinder is 0. So can I say Fr1 Fr1 plus N2 minus mg. Let me draw the free body diagram of this cylinder. Okay, downward there is a mg force. Okay, out here there is N2 force, and out here there is FR1 or friction from wall 1 or friction from vertical 1. So can I say the linear or the vertical acceleration of this block from vertical acceleration of this cylinder is equals to 0? So I can say that friction force due to 1 plus N2 minus mg is equals to mass into acceleration, or acceleration is equals to 0, or vertical acceleration is equals to 0. Similarly, the horizontal acceleration of center of mass of this block is also 0, isn't it? So if I write down the horizontal equation, what are the horizontal forces? N1, N1, okay, and F2 or friction force 2. So I can also write down N1 minus Fr2 is equals to 0. This is the horizontal component of force. Okay, so from the second equation, I can easily say that N1 is equals to friction force from wall 2. So N1 is equals to Fr2. This is from the second equation. Okay, N1 is equals to friction force from wall 2. Okay, now what is the value of this N2? Okay, okay, one more thing. Friction force 1 and friction force 2 are nothing but, what is the formula for friction force? Friction force is nothing but coefficient of friction into normal reaction force, isn't it? Friction force on wall 1 is equals to coefficient of friction in this wall into normal reaction force. Similarly, formula for friction force is nothing but coefficient of friction into normal reaction force. So friction force on this wall would be coefficient of friction into N2, isn't it? So let me write down N1 is equals to K N2. Okay, and let me rewrite my equation 1 as Fr1. Fr1 is nothing but Kn1. Okay, so Kn1 plus N2 minus Mg is equals to 0. This is nothing but equation 1. I've just substituted the value of Fr1 as Kn1 and Fr2 as Kn2. Okay, so from equation 2, I get Kn2 is nothing but N1. Okay, or which do I substitute? Let me substitute N1. N1 is equals to Kn2. So out here, I'll substitute N1. N1 is nothing but Kn2. So K into Kn2 plus N2 minus Mg is equals to 0, or K square into plus N2 minus Mg is equals to 0, or K square plus 1 into N2 is equals to Mg, or N2 is equals to Mg by K square plus 1. Okay, I found out the value of normal reaction force due to this bottom surface or horizontal surface. Now, if I want to find out the value of N1, N1 is nothing but K into N2. So if I just multiply this entire parameter by K, I'll get the value of N1. So out here, N1 is nothing but K into N2, where N2 is nothing but this value. So K into Mg by K square plus 1, K square plus 1, K into this value, Mg by K square plus 1. So I got the value of N1, I got the value of N2. I got the value of N1, I got the value of N2. What is the question asking us? The question is asking us how much turns. To find out the number of turns, I need the value of angular acceleration. So let's now make the torque equation and find out the angular acceleration. Okay. Now to make the torque equation, the first thing we have to determine is what is the axis of rotation. Okay. Axis of rotation is nothing but throughout the center of the disc or center of the cylinder. So if this is the center of the cylinder, or if this is the axis of the cylinder, what are the forces that is causing the torque? Okay, there are 4 forces acting on the cylinder. N1, N2, friction force on the due to this left wall, Fr1, and friction force due to bottom wall, Fr2. Okay, so see, and Mg. These are the 5 forces that you have. Okay, if you see properly, N1 is passing through the center. Okay, so torque is nothing but R cross F. So R cross F out here due to N1 would be 0. Similarly, R cross F due to N2 would also be 0. Mg is also, or Mg also acts to the center of mass. Okay, one thing you should always remember in mechanics, that gravity forces passes through the center of mass of the body. Okay, so out here Mg forces, okay, or gravity force also pass through the center of mass of this cylinder, isn't it? So torque due to gravity force is also 0. Now see, friction forces acts on the surface of body or surface of contact. So this friction force and this friction force will create a torque. Okay, so torque equation. Let me write down the torque equation. Torque equation. And why am I finding out the torque equation? To find out the angular retardation alpha. Okay, So torque retardation is nothing but Fr1 or friction force 1 into R. R is nothing but the radius of the circle. And Fr2. Acha. Plus Fr2 or minus Fr2. This should be plus Fr2 or minus Fr2. See. Friction force is acting upward. That means friction force is trying to rotate in this direction. Okay. Angular acceleration is also in this direction. Friction force Fr2 is also trying to rotate this cylinder in clockwise direction. So this torque and this torque would be added. So Fr1 plus Fr2 plus Fr2 into R. So torque due to this friction force plus torque due to this friction force is equals to moment of inertia of the cylinder into angular acceleration of the cylinder, isn't it? Okay. Now if I have to find out Fr1, Fr2, or let me substitute all the values in this. Okay. This is a cylinder, solid cylinder, okay, of mass m, given in the question. Mass m. What is the moment of inertia? Moment of inertia is nothing but a mass square by 2. Okay. What is the value of angular acceleration? Let that be alpha, because we're dealing with rotational dynamics. No, there is no parameter of linear acceleration asked. Okay. One more thing you might guess, sir, why did you make the linear acceleration out as 0? See, in the previous question, I was considered about the linear acceleration at the surface. Okay, but in this diagram, the linear acceleration of center of mass. Why? Because all this force, all this linear force, if it causes a linear acceleration, okay, the linear acceleration of center of mass would change. But since there is only rotational acceleration, the linear acceleration of various points in the disk would be very different. But the linear acceleration of center of mass would be 0. Okay, that means if a body is not translating or moving, the velocity of center of mass or the linear velocity of center of mass is equals to 0. Understood? That means net force is equals to 0. Okay. Though the net torque out here is not equals to 0, the net torque is additive in nature, which causes an angular acceleration. Okay, let me get back to the question. The value of friction force due to left wall. Friction force is nothing but Fr1. What is the value of Fr1? K into N1. Fr1 is nothing but K into N1. Our value of N1 is nothing but Kmg by K square plus 1. So Fr1, let me write it out here. Fr1 is equals to K into N1. Kn1, where N1 is equals to how much? N1 is equals to Kmg by K square plus 1. Okay. Kmg by K square plus 1. Fr2 is nothing but Kn2. Our value of N2 is nothing but how much? Mg by K square plus 1. So Mg by K square plus 1. Okay. So Fr1. Okay. Or let me cancel out the R also. Let me cancel out this R. So I'll get Fr1 plus Fr2 is equals to Mr by 2 into alpha. So let me write out the value of Fr1. Fr1 is nothing but K into N1. So K into what is the value of N1? Kmg by K square plus 1. Kmg by K square plus 1. Okay. Plus Fr2. What is the value of Fr2? Kn2. Or K into what is the value of N2? Mg by K square plus 1. Mg by K square plus 1 is equals to Mr by 2 into alpha. Okay. Let me take Mg by K square plus 1. Mg by K square plus 1 common. If I take that one, or Mg by K square plus 1 common, I'll get K square plus K is equals to Mr by 2 alpha. Or M and M would get cancelled. Is there anything else that is getting cancelled? I don't think so. So K into K plus 1. Why K into K plus 1? This can be written as K into K plus 1. Okay. K into K plus 1 is nothing but K square plus K. Okay. So let me write this as G into K square plus 1 into K plus 1. Okay. Is equals to R by 2 alpha. Or alpha is equals to, send this R by 2 to the left hand side. So 2gk into k plus 1 divided by k square plus 1 into capital R is equals to alpha. Now we have found out the value of alpha, isn't it? So if the value of angular acceleration is found out, if the initial velocity is given, can you find out the total displacement or total angular displacement before it becomes 0? Obviously, I'll use the formula. How much? V square is equals to u square plus 2as, isn't it? In rotational, it becomes final angular velocity square is equals to initial angular velocity square plus 2 into angular acceleration into angular displacement, isn't it? Final angular velocity is nothing but 0, because when it stops, it becomes 0. Initial angular speed is given as omega or minus omega. Why minus omega? because the direction of, see, in the direction of anti-clockwise. See, this is my right hand. The screen might be mirrored, but note this is my right hand. Okay. If the direction of angular acceleration is in this direction, the direction of, sorry, if the direction of angular acceleration is in this direction, the direction of angular velocity would be in this direction. So if one of the direction is positive, the other one direction would be negative. It doesn't matter in this question which direction you take as positive, which direction is taken negative. Just remember, if you take the direction of angular velocity as positive, take the direction of angular acceleration as negative. If you take this as positive, take this as negative. Okay. So omega initial is nothing but omega or minus omega square plus 2s plus 2 into, what is the value of alpha? Alpha is nothing but 2gk into k plus 1 divided by k square plus 1 r, k square plus 1 r into theta. Okay. Or we could do one more thing. Okay. Minus omega square. Omega square out here minus. I'm taking the direction of acceleration minus. Now you might have said it doesn't make a difference. Why are you doing it like that? Okay. See, if this goes to the left hand side, omega square, I have to make a root, no? Okay. So if I do not take the minus out here, what will become root under root of negative kind of thing. If this entire positive thing goes to the left hand side and becomes negative, under root of negative is the imaginary number. Okay. That's why I took the minus in the acceleration side. Now see, omega square is equal to, take this entire term to the left hand side. Okay. So 2 into 2. 2 into 2 is nothing but 4. 4 gk 4 gk into k plus 1 divided by k square plus 1 into r into theta. So we have to find out the value of theta or theta displacement. Theta is equals to, take this entire term to the left hand side, omega square k square plus 1 into r divided by 4gk into k plus 1. Okay. So this is the number of revolution, or this is the number of angular displacement this entire thing does before it comes to stop. Clear and fine. One more problem is that the angular displacement that I found out here is in radians. Okay. Whenever I'm using SI units out here, the angular displacement that will be found out here will be in radians. The question is asking, find out the number of turns. How many turns will the cylinder accomplish before it stops? So angular displacement out here is found in radians. So if I want to convert radians into number of turns, how do I do that? Number of turns is equals to radians divided by 2 pi. Why? Because one full revolution is equals to 2 pi radians, isn't it? One full revolution is equals to 2 pi radians. Okay. So 1 radian is equals to number of revolution over 1 full revolution divided by 2 pi. So theta radians is equals to theta theta by 2 pi number of revolutions, isn't it? See, if 1 revolution is equals to 2 pi radians, okay, 1 radian should be equals to 1 by 2 pi number of revolution. So theta radian would be theta into 1 by 2 pi number of revolution. So if you divide the entire thing by 2 pi, we get the number of revolution. So number of revolution before the entire disk comes to stop is nothing but a number of revolution. Number of revolution is nothing but this entire parameter divided by 2 pi is equals to theta divided by 2 pi, or 4gk into k plus 1, sorry, not 4gk, or this one, okay, this one, omega square into k square plus 1 into r divided by 4gk into k plus 1, okay, divided by 2 pi into 1 by 2 pi. Okay, so this was the answer to question number how much? 1.248. Now this question is very similar to clutches. Okay, you haven't often heard clutches. Okay, disc brake. So this numerical that you are about to do is very similar to those kind of concepts. So if you understand this one, we'll get a greater understanding of what or how clutches work or how disc brake work. And this also has a greater probability of coming in your exam. Okay. See, in this question, what is happening is, suppose there is a disc. Okay, there is a flat disc out here. The mass of this disc is nothing but m. Okay, the mass of this disc is m. Now this is kept on a surface. Okay, this disc is kept on a surface. Fine. Now suppose it was given an initial angular velocity of omega. Okay, after a certain while this will stop. And why is this stopping rotating, or why does this stop, or why does this disc stop rotating? Because there is an friction force. Okay, friction force from the table onto the disc, isn't it? That friction torque, not friction force, friction torque. Okay, and that friction torque is causing this disc to stop. And we'll analyze this motion in numerical thing. Okay, in numerical way. So out here, I'm seeing this disc from the top. Okay, so if I see this disc from the top, it was initially rotating with angular velocity omega. Okay, this disc of mass m is initially rotating with angular velocity omega. Fair and fine. Okay, how long will the disc be rotating? That means find out the time for which the disc rotates if the friction force is active. Fair and fine. Okay, this is the side view of the disc. Side view means when I view the disc from the side, it will look somewhat like this, isn't it? So out here there is friction force. Okay, now how do I find out the torque in this entire disc? Okay, see, the reaction forces or the friction forces out here would be something. Okay, the friction force out here would be mu into m into g. Out here the friction force would be mu into m into g. But if you notice something, the torque out here would be very different from the torque at the center. That would be very different from the torque at the edge. And why is that? Because the distance where the force is applied is very much far from the center. Okay, and torque is nothing but r cross f. So torque out here or at the edge of the disc would be much greater than torque at the center. So how do I add up all this torque to find out the total torque acting on this disc? So whenever there is a disc, how do I divide the disc? Disc is nothing but a collection of rings, isn't it? Suppose I make an elemental ring. Okay, elemental ring. That means this disc, okay, this disc was divided into elemental ring of thickness dr and mass dm. The mass of this ring is nothing but dm and the thickness of this ring is nothing but dr. The mass of this ring is dm and the thickness of this ring is dr. Okay. Now if I see this ring, okay, this ring is pushing on the table. So what is the normal reaction force? The normal reaction force is nothing but mg or dm, mass of the ring, into g. What is the friction force out here? The friction force out here would be nothing but, suppose if the ring is rotating in this direction. If the ring is rotating in this direction, okay, the friction force out here would be out here friction force, which is equals to mu n, isn't it? The friction force at this point would be in this direction, mu n. The friction force at this point would be in this direction, which is equals to mu n. Similarly, the friction force out here would be in this direction, mu n. So if you see, the friction force at this, every value of friction force is putting a torque in the same direction. The value of torque due to this friction force, or due to friction force out here, would be mu nr. The value of friction force, the value of torque, friction torque due to this friction force would be mu nr. So the value of friction torque in this entire ring is same throughout, which is equals to mu nr. So elemental torque in this ring is nothing but mu n r, where r is nothing but the radius of the ring. R is nothing but radius of the ring. Okay, r is nothing but radius of the ring. Okay, so elemental torque on this ring is nothing but coefficient of friction. Okay, see, in irodov, instead of using mu, they use k. Okay, instead of using mu, irodov use the notation of k. This is nothing but coefficient of friction. K n r, where n is nothing but mass of the ring into g. So elemental torque is nothing but k dm, or elemental mass, into g into r. Fair and fine. So if the elemental torque on this ring is nothing but this value, what is the total torque on the entire solid disk? The total torque on the entire solid disk is nothing but d torque. You have to integrate the torque from zero radius to, sorry, the torque at the center is equals to 0, the torque at the side is equals to maximum. Okay, so integration of elemental torque is nothing but k dm gr. Okay, k dm gr, this value, and you have to integrate this value from r is equals to 0 to r is equals to capital R, or from the center to the surface, from the center to the surface. Okay, now when I find out the total torque acting on this disc, I can find out the angular acceleration or angular retardation. If I can find out the angular retardation, I can find out at what time it will stop rotating. Okay. So the first thing out here is I have to find out the elemental mass in terms of total mass. The total mass of the ring is given as m. Okay. So can I say the planar density? Planar density means total mass divided by total area. Planar density of the disk is nothing but m divided by pi into capital R square. Planar density or area density of this disk is nothing but mass of the disk divided by area of the disk, which is equals to planar density of the ring, isn't it? Why? Because this ring and the disk is made up of same material, so both will have the same density. Okay, so what is the density or what is the planar density of this ring? mass of the ring divided by surface area of the ring. Sorry. And what is the surface area of the ring? 2 pi r dr. Surface area of the ring is nothing but 2 pi r dr. So from these two equations, can I find out the value of dm? Obviously. So m by pi r square is equal to dm by 2 pi r dr. Okay. What can be cancelled? Pi and pi can be cancelled. So dm is equals to 2r dr into total mass is equals to dm. Now, if I substitute this elemental mass or if I substitute this formula out here, what do I get? Total torque or integration of total torque 0 to t d tau is equals to r is equals to 0 to r is equals to capital R. K will remain constant. The value of dm is nothing but how much? M into 2r dr. M into 2r dr into g into r into this value g into r. Okay. So total torque. Let me take out the constant term outside. What is constant out here? K is constant. Total mass of the disk is constant out here. G is constant. And 2 is also constant. So 2 km, 2 km and G. And inside the bracket, it is nothing but R into R square dr. R square dr. Okay. So total torque is equals to 2 kmg. What is the integration of R square dr? R square dr is nothing but R cube by 3. So R cube by 3. The lower limit is 0, upper limit is capital R. So the total torque on the disk is equals to 2 kmg capital R cube by 3. Understood? So this is the total torque acting on the disk. If this is the total torque acting on the disk, what is the acceleration or what is the angular retardation of the disk? Torque is equals to I alpha. I can easily write out torque is equals to I alpha. The value of total torque on the disk is nothing but how much? 2 kmg R cube by 3. Okay. 2 kmg R cube by 3. What is the moment of inertia of this disk? Or what is the moment of inertia of a solid disk of radius r? M square by 2. So moment of inertia would be m square by 2. And by using this formula, you find out the angular acceleration. So 2 kmg r cube by 3 is equals to m r square by 2. M and m will get cancelled. R square and r cube would become capital R. Okay. Into alpha. I have missed out this alpha, no? This alpha should be written out here. So what is the value of alpha? Value of alpha is nothing but, let's take this 2 to the right hand side. 2 into 2 is nothing but 4 kgr divided by 3 is equals to alpha. So angular acceleration of the disk is nothing but 4 kgr by 3 or 4 into coefficient of friction into g into r by 3. Okay. So the retardation of this disk in the opposite direction would be nothing but 4 kgr by 3. Now what the question is asking? Find out the time at which the disk will stop rotating. So I can easily apply v is equals to u plus at. The rotational equivalent is nothing but final angular velocity is equals to initial angular velocity plus angular acceleration into time. When the disk stops, what is the final angular velocity? 0. What is the initial angular velocity? The initial angular velocity is given in the question. Omega. See? Initial angular velocity is given as omega. Omega. What is the value of acceleration? The value of acceleration is nothing but 4 kgr by 3. 4 kgr by 3. And I have to introduce a minus out here. Tell me, why did I introduce a minus? Why was this minus introduced? Because out here, the direction of angular acceleration is opposite to the direction of angular velocity, isn't it? So if angular velocity vector is in this direction, angular acceleration would be in this direction. Okay, that's why a minus is out here, because angular velocity vector and angular acceleration vector are in opposite direction. So if I write out this equation, 0 is equals to omega minus 4 kgr by 3 into t, or omega is equals to 4 kgr by 3t. So to find out the value of t, or t is equals to 3 omega into 3 omega divided by 4 kgr. So at this time, the disk will stop rotating. Okay. See, one more thing that I said, this is very useful in clutches and things. Okay. One thing you might note out here, the pressure exerted by the disc on the surface can be regarded as uniform. Why was this line important? Okay. See, whenever you study about clutches or disc brake or any kind of that material in engineering, basically there are two kind of theory. Okay. Uniform pressure theory and uniform wear theory. Okay. Basically two theories: uniform pressure theory, uniform wear theory. The theory or the numerical that I have done out here is exactly the way uniform pressure theory is applied. Okay. Uniform wear theory is currently outside your scope of syllabus or scope of JEE syllabus. Okay, this is just an additional okay, uniform pressure theory and uniform wear theory. Uniform wear theory. The numericals of this is little bit outside your scope of syllabus. The thing that you did out here was exactly uniform pressure theory, or exactly the numerical type of calculation that you do in uniform pressure theory. Okay, so that's it for question number 1.249.